Hello everyone, my name is Anthony Bramante, and today the Raade engineering team and I will discuss the Coastal Rail Trail project located in Oceanside, California. I, along with Eric Perez, Drew McLaughlin, Alfonso Ramos, and Ramiro Ramirez, will explain the design that Raade Engineering has procured for this community project. The overall goal of our project is to extend the reach of the current coastal rail trail that runs up the coast of Oceanside for pedestrians and bicyclists to travel on. The trail will connect the existing segment intersecting Oceanside Boulevard to the existing segment that is adjacent to Myers Street via a bridge crossing the Loma Alta Creek. The rest of the project will provide connections to the trail from Buccaneer Park, which is below, with a pedestrian ramp, as well as a proposed parking lot where the La Salina wastewater treatment plant currently resides. I will now pass the presentation on to my colleague Eric, who will be discussing the site geotechnical conditions and bridge abutment design.
The site is mainly composed of silty sands to clayey sands, fine-grained and minor gravel, which are all ideal for drainage purposes having high hydraulic conductivity. Therefore, the fill going up against the retaining wall will also be composed of silty sand to help with runoff conveyance and ensure that our stormwater system is as effective as possible. Also, the test made by Taylor Group Inc. gave us useful information regarding the soil's density, shear strength, and consolidation, which are key parameters to determine the soil's load-bearing capacity and therefore design our foundations for the exact type of soil. Based on this criteria, our abutments were designed to not only support the bridge, but also the towers for the suspension cables. Because of the uneven terrain, we had to design two different types of abutments, one for each side of Loma Alta Creek with different heights to maintain the constant elevation for the bikeway. Continuing with design, Drew will examine the pedestrian bridge and the main components include.
For the design of the bridge, we took careful consideration to the impact on the surrounding environment and local wildlife. In order to prevent affecting the local ecosystems, we decided to design a suspension bridge that excluded the use of piers in the middle of the bridge span. This allows for the bridge design to avoid making large changes to Loma Alta Creek that the pedestrian bridge passes over. Pictured here are the plans for the proposed suspension bridge across Loma Alta Creek. The bridge slab is constructed from pre-stressed concrete with steel tendons to maintain the strength of the slab. The suspension bridge rests on abutments that lie on each side of the creek, spanning 255 feet. Each side of the bridge along the slab contains a carbon steel railing with metal rope in between the slab and the top of the railing to contain the foot and bike traffic within the pedestrian pathway. 25 steel tension cables on each side are connected to a 7-inch diameter main tension cable that spans across the entire bridgeway. Moving past the bridge design, I will now pass it on to Alfonso for the retaining wall design for the Coastal Rail Trail project.
So the retaining walls were based on the grading done by our transportation engineer, Ramiro Ramirez. From the grading, we were able to find the height required for the wall to retain the soil. Raade Engineering has therefore designed a wall with a max height of about 30 feet and slopes down to a height of about 19 feet. The backfill for the retaining walls will require to have a limited slope of ratio 2:1. This is due to the proximity of the bike path, which is only about 2 feet away from the backfill slope. The retaining walls will have a pile footing, which is the best fit for a project. This is due to the current site conditions, which are not as favorable for supporting heavy loads. The design of the retaining walls were determined after calculating for both stability and strength, such as overturning, sliding, and steel reinforcement. My colleague Ramiro will now talk about the transportation part of the project.
Based on the existing grade conditions and up to code design criteria for Class 1 bikeways, the alignment of the bikeway was determined. Here is a cross-section that displays the dimensions of the bikeway. The bikeway is going to consist of a 10 feet travelway and 2 feet shoulders. The bikeway is also going to consist of 5 horizontal curves and 2 main vertical curves. Starting from Oceanside Boulevard, appropriate signage and striping is going to be installed to provide comprehensive and safe travel along the bikeway, while also maintaining a contiguous feel with the rest of the Oceanside Coastal Rail Trail. Here is the plans for the proposed signage and striping. This bikeway will allow pedestrians and bicyclists alike to enjoy the sights of Buccaneer Park on a sunny day.
For the rainy days, our drainage system will effectively deliver stormwater to the Loma Alta Creek, further minimizing our impact on the environment. Firstly, the stormwater will collect in the open channel swale adjacent to the bikeway and travel down to the bridge, where a drainage pipe will receive it and then discharge it through scuppers on both sides of the bridge. We are privileged to have been able to work on this project and employ our combined strengths in engineering and problem solving to design and contribute to the great vision that is the Oceanside Coastal Rail Trail. Raade Engineering is confident that the time and dedication our team has put forth for this project shows in the composition and detail of the overall project design. Thank you oh so much for your time.